Hi, this video is going to help with section 12.2 of geometry, or in a different textbook, over chords and arcs. So let's look at, first of all, what a chord is. So what a chord is when you have one endpoint in both endpoints are on one end of the circle, forms a chord. If it goes through the center, it's the diameter. So most of us know that word diameter, but chord is anything but when it goes through the center. It's still a chord, but it's also called the diameter when it goes to the center. An arc is a portion of the circle that we have seen in a couple problems before, but just in case, I drew a picture of an arc there for you. There are 1, 2, 3, 4, 5, 6, well, there's 7 different theorems. I'm going to go through them kind of fast, and I want you to look at them in the textbook a little bit more, write them down to help you remember them. So I wrote them down in words, and I wrote them as simple as I could. My picture is going to help me with all of these ones I'm looking at here. 12.4 says congruent central angles have congruent arcs. So if these central angles are congruent, whether you're looking at two separate circles that are congruent or two pieces in a circle like this one, there's two ways you can kind of look at that. If these central angles are congruent, then the arcs are congruent, because whatever this central angle is, that's what the arc is. So that makes sense. So congruent central angles have congruent chords. This is new. So if these two have congruent central angles, then the chords are the same distance across. Congruent chords have congruent central angles. So if you start with the chords being congruent, then the central angles are congruent. So that one works a couple ways. This last one, if chords are equidistant from the center, then or centers are congruent. Oops, how did I write that? Write that wrong. Chords equidistant from the center, then I think this should say then the centers are congruent, or the chords, I mean. Or let me get that one anyway. So look at the picture. What it's saying is, if you have chord, here's two chords that are equidistant from the center. See, those are equidistant, and that is perpendicular to it. Then AB and CD are congruent to each other. Yeah, how did I say that? 12.7. Or centers. Yeah, no, that's centers are congruent. Chords. I think I just stated it wrong, but here's the idea of it. If you're equidistant from the two chords, then the chords are congruent. All right. The next kind of theorem that I went over is here. So this one had 3 theorems with it, 12, 8, 9, and 10. And this one is saying different things about a chord that is cutting the diameter. So if AB and this chord CD are perpendicular, then we can say that these two pieces are congruent, and these two arc chunks are congruent as well. So then that's one of them. Another one will say, well, if you know that this is the diameter, then these two are congruent. And if you know that these two are perpendicular, then you know that they're perpendicular. Let me say that again. If we know this is the diameter, then these two are congruent, and you know it's perpendicular. So it's kind of working all sorts of different ways. And then 12.10 is saying, if you start with the perpendicular bisector, then you know AB has the center. So if you start with perpendicular and bisector, then you know AB is going to be the center. So all of those had to do with, okay, if you know these two are congruent, well then that one is perpendicular and it goes through the center. And if you have this and you know this, and you also know that this is congruent to this. And so look through those. It gives us quite a few things. But let's look at the problems that you're going to see that are related to this one. So let me cover my work on that one. So if I see this circle here, And I'm saying, okay, here's AB and it's a chord and O is the center and we're going to go up and we're going to hit that chord. And we're perpendicular. This is 3, this one's 10. How can we find that radius? Okay, well, here's how I thought of it. I thought, well, I can draw a line from O to B and form a triangle that looks like this. We also know if this is perpendicular that that 10 is going to break into half because that has to bisect the chord, leaving each side 5, 5 and 5. So if you look at taking this triangle and writing it here, this side would be 3, this side would be 5. I could easily find this side right here, which is a radius. All radiuses are the same. So I can use the Pythagorean Theorem. 3 squared plus 5 squared is 9 plus 25, which is 34, and the square root is about 5.8. And I don't think it asks you to keep it in square root form. Now I was just thinking of that. But if it does, then you have to simplify that square root of 34 and leave it in that form. Let me think if you can simplify that one real quick. I don't think you can. 34 divided by anything. I don't think so. So it would just be the square root of 34 on this one. Okay. Now let's look at this next example I have here. If two circles are crossing each other, oh, they're kind of light, but here you can see the circle and the circle. My AB is really big. That's good. And then CD is here, and it is a chord. See how that CD is a chord on both? And it says, well, what if the radius is 25 and we know CD is 14? What is AB? Well, think about this. We know that this is going through the centers and it's going to have to break that CD in half because it's a chord. So that means each of these is going to be 7. And again, this would form a triangle, which I'm going to draw. And that triangle is going to have the radius for AC and CB of 25 that we were given. And then we know CD is half of it is 7. So we look at that as 7. See my little tiny 7 there. And we can use that Pythagorean theorem again. So we'd know 7 squared plus x squared. Look at this side. Either one would be the same, but 7 squared plus x squared has to equal 25 squared. 7 squared is 49. 25 squared is 625. So be careful that this is the hypotenuse. So you have to subtract the 49 from the 625 to get 576. Square root that and you get a really pretty number of 24. So x is 24. What did it ask you though? Be careful what you enter into Math Excel. It asks AB. Well, we know AB have to be congruent. Based off of, well, I guess we could analyze it through, why would it be congruent? AB has to be congruent because the circles are congruent, and I can't remember what other theorem says that there have to be congruent. I just know that they do. That's not good. If I could list the theorem off the top of my head, for some reason I'm not thinking of why they have to be congruent. Oh, I guess because they form the same triangle here. That's one way we could think of it. So we know AB has to be 48 because both x's have to be 24. So here's kind of how you can use both of these two different ideas. Now there were a lot of theorems that cover this idea and a lot of theorems that kind of cover this idea and some of the other questions. So just make sure you look through those theorems, and maybe if you draw them each, it'll help you remember them or write them depending on how you think. But I wanted to do a couple example problems, and then you still have the virtual nerd that will help you with learning this section as well.